Okay, integration by parts. We're going to be using this formula. I'm not going to prove it. There's a brief sketch proof on the notes that you've been given, but we're going to just assume this because it's in the formula book. So it's called integration by parts. It's like the product rule of integration. If we're integrating things where we've got two things, u and dv dx, both inside the integral, then we can use this formula. It's best done just by starting with an example. It's the same method every time. So let's have a go. We're going to have a go at this thing. Now, this is a classic integration by parts because we've got two things inside the integration. Remember, this dx is just like, it's like the end bracket of an integration. It's not really involved. All we're integrating are the things in here. If it makes it a bit clearer that it's two things, you can think of it as x multiplied by sine x. The tactic with these is to pick one thing to be u and the other thing to be dv dx. Just focus. There is a tactic here. Any just nice powers of x are our priority for picking as u. So I'm going to pick this one to be this thing here, which is an x, and I'm going to pick this thing here to be the other thing, sine of x. Okay, well, to do that, to carry on with the method, we need to work out what v is, and we also need to know what du dx is. I always lay it out in the same way. So u differentiates to du dx, and we'll work out that in a minute. And dv dx, to get back to v, we're going to have to integrate. So we're going to differentiate this one, and we're going to integrate this one. Okay, differentiating this one with respect to x just gives us 1. Notice that it got simpler when we did that. That's the aim of integration by parts. We want the things to get simpler over time. Right, this one, integrating sine of x. You did this last lesson. Sine would differentiate to give cos, so integrates to give minus cos of x. Now, some of you may be worrying because I haven't put plus c here. Don't worry about the plus c, it's not going to come into it. This is one time in integration where it doesn't matter. Right, now let's have a look at this formula at the top. So they're saying that this integration, the thing that we had at the top, is equal to, well, we can just fill in the bits. U times v, which is that thing times that thing. So I'm going to write it as minus x cos x. It's just me multiplying those two together. Minus the integral of whatever v was, which is this thing here, minus cos of x, multiplied by du dx, which in this case is just 1 dx. It's dx because we're just finishing the integral here. Okay, so this thing here was minus x cos x. Notice that we've got a minus and a minus. I can bring this negative out of the integration if I want, so that's the same as plus the integral of cos x dx. Notice the multiply by 1 doesn't do anything here. Okay, integrating cos x. If you've got your trig wheel handy, you'll be able to see that it goes to sine of x. And then once we've done the final integration, once the final integral sign's gone, we've done the actual integration, we're going to put plus c right at the end. So it's the last step that you do. And so this thing integrated to this thing plus this plus c. What we've done by doing an integration by parts is we transformed one integration into another integration. But because this one was simpler, it just had to times by 1 rather than times by x, the whole thing's become easier. Okay, let's have a go at another one. By the way, these are all in the written notes you've been given. You might want to be copying these down as you go. So this is the second one. Right. Again, we've got an integration of two things multiplied together. So I'm going to go, this one is going to be our u. I just want to pick a nice power of x as our thing to be u, which means this thing is our other thing, our dv dx. Right, let's do a second colour again. What we need is du dx by differentiating this one. Well, that's just 1. And we also need to integrate this one to give us what a v is. Well, we can use the reverse chain rule that we did last lesson. So we're still going to have the thing in the bracket. We add 1 to the power. We divide by the new power. And then we're going to divide by, well, in this case, a was just 1. So divide by 1, so it doesn't change. Okay, Right, let's do the actual integration now. Using the formula for parts, this thing, the integral, is equal to u times v, so that thing times that thing, so x over 5 multiplied by x plus 1 to the 5, minus the integral of v times du dx, so that thing times that thing, a fifth x plus 1 all to the power 5 dx. Okay, right, we transformed the integral into this thing and another integral, but this integral is easier because it doesn't have an x at the beginning like this one did. It's just got a constant. Okay, so this is x over 5, x plus 1 to the 5. I'm just going to take the fifth out of the integral. Anytime we have a constant, that's fine. X plus 1 to the 5 dx. Okay, well, integrating this, we're going to have to do some chain rule. So we're going to have x over 5, x plus 1 to the 5 minus a fifth times whatever comes out of this integral. Well, whatever's in this integral is x plus 1. We add 1 to the power, we divide by the new power, and we'd also divide by 1, which doesn't change it. The last integral sign's gone, so I'm going to put a plus c. And now I'm just going to neaten it up a bit. So we've got x over 5, x plus 1 to the 5, minus the fifth, minus the sixth, that's minus a 30th, x plus 1 to the 6 plus c. Okay, I'm going to go through one more example. Sorry, this is getting quite long. Sometimes we're going to need to integrate twice. So this one has an x squared at the beginning. I'm going to go through this quicker. We're going to pick u to be x squared. We're going to pick dv dx to be e to the x. Second colour. du dx, differentiating this one, is 2x. Integrating this one, well, integrating e just keeps it the same, e to the x. And so my original integral here is equal to, well, let's get our formula up again. U times v, so that thing times that thing, x squared e to the x, minus the integral of that thing times that thing, 2x e to the x dx. Okay, this thing in here still has an x multiplied by an e to the x. So what we could do is integration by parts again. It's a bit like we had something like in this very first example where we had an x times by trig. Integrating it by parts swaps it from being something with an x to something with a 1. We can do the same thing here. So separate integration by parts question. On this bit here, we could pick u to be 2x, that thing there. We could pick dv dx to be e to the x. Second colour. Differentiating du dx equals 2. And v, integrating this one, is e to the x. And so, doing integration by parts, we're going to have to be a bit careful here. This thing up here, well, we haven't changed the start. We've still got x squared e to the x. And we were doing minus the integral of, I'm just going to put some big brackets here. Whatever this integral was, we can work out from here. Right, integration by parts is uv, so those two, 2x e to the x, minus the integral of that times that, 2e to the x dx. Notice that this bit here is like a little sub-question of integration by parts. It's just that bit there, is that bit there. I put it in brackets because this was minus, because this was minus. Right, last bit, we don't have to use integration by parts again because this final integral we can actually just integrate. So we've got minus this bit, 2x e to the x. Minus times minus is plus. And this thing, integrating e to the x, is e to the x. So 2 e to the x, it just stays the same. Final thing I need to remember, plus c. Remember, whenever the last integral sign goes, we're going to get plus c. Right, this has turned into quite a mammoth video. So I'm going to give you a question to have a go at. It's simpler than that last one. Here's a question for you. So have a go. It's very similar to the first one. Pick what u is, pick what dv dx is, and then see if you can follow through the method. Formula's still just about up here. Right, pause the video, have a go. Okay, we're going to pick u to be 2x. We're going to pick dv dx to be the other bit, cos x. Going to use a second colour. Differentiating du dx, well, that's just 2. And this bit here, v equals sine of x. Cos integrates to sine. Very easy to get the minus sign wrong there. It's positive. Right. Using the formula, this is equal to u times v, which is 2x sine x, minus the integral of that times that, 2 sine x dx, which is 2x sine x minus, we've still got the 2, that didn't affect it, sine integrates to minus cos of x plus c, and just neating out, we've got 2 negatives, so that's the same as having a positive. Plus 2 cos of x plus c. Right, these are hard, but it's always the same method. My advice is just lay it out the same way each time. I always put u here, I put dv dx here, differentiate, integrate, and then stick the things into the formula and work out what you've got. On the worksheet, there are lots of questions for you to try. Have a go. They're very similar. You'll get the hang of it eventually.